Traditional enterprise IT architecture is built on deterministic logic. You write a rule, the system executes the rule, and the output is entirely predictable. Modern artificial intelligence operates on probabilities. It adapts, learns, and generates outputs that its own developers might not anticipate. When organizations attempt to govern these adaptive, probabilistic systems using old checklists designed for rigid software, the frameworks break down. A static security audit cannot manage a generative model that continuously updates its own internal parameters. In highly regulated environments, this structural friction produces severe consequences. In the financial sector, it surfaces as discriminatory algorithmic lending. In healthcare, it results in erroneous clinical outputs and privacy violations that breach patient trust. The root of the problem is fragmentation. Organizations typically isolate data management, cybersecurity, and enterprise risk into distinct, disconnected silos. The AI development team rarely communicates with the corporate risk committee until something goes wrong. These blind spots allow latent vulnerabilities to propagate across the entire development pipeline. By the time a model is deployed, those hidden flaws manifest as cross-border compliance infractions, security breaches, and massive data drift. To deploy AI safely, we must replace disjointed checklists with a vertically integrated stack. This diagram outlines a comprehensive 5-layer enterprise AI governance framework. Under global standards like the EU AI Act, this approach is the only way to maintain systemic accountability. The top of this stack is the strategic governance layer. This is where executives evaluate enterprise readiness, calibrate risk appetites, and align AI investments with broader organizational goals before a single line of code is written. When enterprise AI initiatives collapse, the failure rarely starts in the development environment. It originates here, at the executive level, through a mismatch between the company's technical ambition and its actual regulatory readiness. Despite its importance, recent literature reviews show that strategic governance is currently the weakest, least formalized layer across enterprise sectors. Executive teams are prioritizing speed over structured oversight. To correct this, research points to the Gen AI Strategic Assessment, or GSA, framework. The GSA provides decision-makers with a quantifiable, weighted scoring system to evaluate potential AI deployments. Instead of green-lighting projects based on hype, the GSA filters every initiative through strict pillars: value chain optimization, market reconfiguration, organizational readiness, and the external regulatory landscape. By requiring a rigorous go-no-go evaluation at the executive tier, companies prevent massive capital misallocation and eliminate downstream regulatory exposure before it even begins. Once an initiative is approved, we move down to lifecycle and operational governance. This layer dictates how models are actually designed, validated, tested, and continuously monitored in production. Driven by mounting regulatory pressure and the rise of machine learning operations, or MLOps, this layer is seeing rapid formalization. Organizations are building highly structured development pipelines. A periodic compliance review every 6 months is useless for an AI system that processes live data. Operations require continuous, real-time risk integration tracking model performance by the second. The Adaptive AI Governance Framework, or AAGF, solves this by embedding regulatory controls directly into the MLOps workflow. It assigns dynamic risk assessments to models, automatically triggering validation gates based on technical complexity and regulatory burden. Empirical data on the AAGF shows immense operational benefits. Studies spanning technology and finance demonstrate a 45% reduction in governance approval time and a 73% increase in the speed of risk detection. Embedding risk-tiered compliance into the pipeline proves that strong governance does not slow innovation. It actively accelerates development velocity because the oversight is automated and continuous. As we descend to the third layer, we move past predictive analytics into the governance of autonomous agentic systems. Warning tone: this is the bleeding edge of enterprise risk. Agentic governance is severely under-theorized, largely unstandardized, and poses an immediate threat to organizations deploying these systems.
Governing an autonomous agent requires an entirely different methodology than auditing a static predictive model. You are no longer checking fixed outputs. You are trying to regulate independent entities that orchestrate tasks and continuously adapt to dynamic environments. When multiple agents operate simultaneously, they interact. They generate distributed decision chains and initiate actions their developers never explicitly programmed. This unintended escalation makes it incredibly difficult to attribute errors to a responsible human entity. To establish behavioral constraints, researchers developed the PTSA architecture. PTSA stands for Personality, Task, Skill, and Accountability. It creates a defined envelope that limits how an agent can behave and tracks every decision it makes. The system requires strict agent-to-agent communication protocols and hard-coded boundaries to prevent models from exceeding their authorized permissions. Without these constraints, autonomous architectures generate opaque operations. If an enterprise cannot audit its system's behavior, it is in direct violation of foundational regulatory requirements. That brings us to the fourth layer: explainability, ethical oversight, and human control. This is where organizations operationalize interpretability, mitigate bias, and ensure human intervention. Deploying explainable AI, or XAI, across fragmented, multi-cloud enterprise networks is exceptionally difficult. Models often serve diverse user groups under varying cross-border compliance constraints, creating a massive technical burden to maintain accuracy while offering transparency. Engineers use techniques like surrogate modeling and feature importance ranking to solve this. These tools probe deep, opaque neural networks and extract the underlying logic into actionable, readable rules that humans can actually understand and verify. However, generating an explanation is only half the requirement. Enterprises must build formal, human-in-the-loop oversight mechanisms. This means establishing auditable escalation pathways and clear competency requirements for the humans overriding the machine. Algorithmic interpretability is no longer an optional enterprise feature meant to build consumer trust. Under mandates like the EU AI Act, role-specific, auditable explanations are a strict legal requirement for high-risk deployments. Finally, we reach the foundational substrate of the architecture: data, cloud, and infrastructure governance. This is by far the most mature layer in the stack. Decades of GDPR compliance and heavy cybersecurity standards like NIST and ISO have forced organizations to institutionalize privacy practices long before advanced AI arrived. This layer dictates data localization, enforces granular access controls, and blocks privacy leakage across highly distributed, global multi-cloud environments. But generative AI places extreme new stress on this foundation. Traditional data governance was built for structured datasets. Modern AI relies on unstructured, high-dimensional, and synthetic data, which raises entirely new questions about provenance and copyright. Tracking where data originated and how it moved across multiple international regions during model training requires AI-driven metadata analysis and predictive auditing. Classical data governance is no longer sufficient. The technical infrastructure must evolve into a dynamic, AI-aware substrate capable of supporting the massive weight of the layers above it. This graphic maps out an interdependent ecosystem. Top-down integration ensures executive risk appetite passes directly down through operational pipelines, constraining autonomous agents. Simultaneously, a reverse flow of cloud telemetry and compliance data must travel back up to inform strategic oversight. The literature is clear on the main vulnerability here. Highly mature cybersecurity at the infrastructure level cannot compensate for a lack of executive alignment at the top or rogue multi-agent behavior in the middle. Organizations face immense danger if they pour capital into basic data compliance while completely neglecting the behavioral oversight of the models making the actual decisions. True systemic accountability in highly regulated environments is only possible when all 5 layers function together as a unified, synchronized architecture.